Hello students, in this video we'll see that the derivative at an interior maximum must vanish. Let's suppose that f is differentiable on AB and that there is a C on the interior of this set, AB, such that f of x is less than or equal to f of c for all x in AB. Of course, this means that C is an interior maximum. So C is an interior maximum. Okay, so C is an interior maximum. Then f prime of C must be equal to 0. Okay, so here's what we're going to do. And so this, of course, should be sort of intuitively obvious. The graph will give us the clue about how to proceed with this. There's x and there's y, and there's your functions. Let's say that that's a, and let's say that it's b over here. If there's a maximum over here, looks like that, it's clear that this point is going to have a 0 derivative, right? The slope over there is going to be 0, right? And that's because the tangent lines going in from the left are increasing, and the tangent lines going in from the right are decreasing. Okay, that's the basic idea. So what we're going to do is we're going to pick two sequences. So here's the proof. Pick two sequences, an, and the an are going to be less than or equal to c, and bn are going to be greater than or equal to c, with an less than or equal to an plus 1. So the an's are going to be increasing, and bn are going to be decreasing. So bn plus 1 less than or equal to bn, right, for all n. So I have a sequence of an that are getting, here's the point C over here. And my sequence A's look like this. There's A1, there's A2, and the B's are over here. There's B1, there's B2, and they're going to get closer and closer and closer to the value C, okay? Good. So in other words, what do we have? With limit as n goes to infinity of an is equal to c, and that's equal to the limit as n goes to infinity of bn. So the an and bn converge to c. Now let's look at the difference quotient at those points. So if I look at f of an minus f of c over an minus c, let's look at the sign of this thing. Well, the f of an is less than f of c by assumption, because f of c is the maximum point, right? And now the an are less than c, so the numerator is negative and the denominator is negative, so this thing is greater than or equal to 0. So as I let n go to infinity, as n goes to infinity, this is a difference quotient, will converge to f prime of c. So f prime of c is greater than or equal to 0 by this condition over here. Now let's go to the other side. Let's look at the bn condition. So the bn condition will say f of bn minus f of c over bn minus c. Well, now, of course, the top is negative because c is the maximum. So in other words, the f of bn can't be any larger than f of c. So the top is going to be negative, and the bottom is going to be what? The bottom is going to be positive. So this thing is going to be less than or equal to 0. And of course, as n goes to infinity, the conclusion here is that this will tend to the what? That's a difference quotient. It tends to f prime of c. So f prime of c is less than or equal to 0 by the preservation of inequalities by limits with an equal sign inclusion. And so I have f prime of c is greater than or equal to 0, and it's less than or equal to 0. So the conclusion from these two things that must be the case. This implies that f prime of c, the derivative of the interior maximum, must be equal to 0. Thank you very much.